I would like to go through some information to give you some ideas on information to study as you prepare for Test 3, which is going to be from Lesson 9A all the way through 13D, but nothing in Lesson 11. The questions, there will be probably about 12 questions on the test, maybe fewer. But right now we're looking at the test. I have a co-teacher and we're looking at it, and right now we do have about 12 questions on the test. It may go down a little bit. It's going to equal out to about a question per lesson section. So with that in mind, we'll start with depreciation. And I cannot stress enough that you truly know and understand the vocabulary. You've got to know the nuances of the words so that when you see a word, you know its meaning and processes that are associated with it. So when you see depreciation, there was also the word appreciate. Also in the objectives, you see where it says interpolate and extrapolate. But as we scroll down, question number 2 has 3 collinear points on it. And something like question 2 would be a great question to put on the test. It has all sorts of information in it, including the pieces under it, where you can estimate, and then you can do as under part B, you can start talking about the basis, the class life, the salvage, depreciable basis. Those pieces are parts that you can pull out, calculate, or write down. Or you could put them in the chart as you see on part C, and then you can talk about whether you used interpolation, and it just means it was within the given dots, the given data points, or extrapolation, which was on the outside, the exterior of our given data points. But one question I really want to point out, and I just went into question number 6, and right here at part E, this turned it all around, and this time it said how long. We had been talking about putting in the years and then calculating the price at that year. And then it turns it on us and says, well, wait, how long would it take for us to get to that amount of money? That would be a really good question to make sure that you understand. Moving on to 9B, a couple of thoughts come to mind on 9B. We did work problems with the triangles. I would refresh your mind memories on how we did information with the triangles, where we were talking about the Durango at year 2, the Durango at year 9, and then trying to calculate what was going on with year 5. I am leaning more towards not putting the triangles on there, but putting the formula. And so I'm going to point you to right above question 5. And let me hit pause, and I'm going to go get this information. I took a screenshot of where we were just above question 5 on lesson 9B. And I filled in the pieces that disappear sometimes when we print from the document in my math lab. And you would not need to memorize this formula, but what you would need to do is know how to, when given 2 points, label them. Label one X sub A, Y sub A, and the other X sub B and Y sub B. And then there would be an intermediate point pointed out. That means it would contain the plane X and the plane Y. And you would be looking for the plane Y, which is here, and the plane X would go here in the formula. So I would practice how to receive the formula and then how to plug in the values and then follow order of operations to come up with a correct calculation for what this Y value would be that we are looking for. Moving on to lesson 9C. I'm going to just scroll through lots of good information about life and jobs and degrees, but I want to scroll down to a couple of parts. Like right here, when it asks, is this statistic univariate or bivariate? Can you read through a paragraph and pick out whether it's univariate or bivariate and then name the variables? In this particular problem, it was talking about salary, and then it was talking about different degrees. So in other words, your salary was going to be impacted by your degree. Like if you had a bachelor's, you should make 1 salary. Ideally, if you have a master's, you'll be making more, and then the same thing if you had a doctorate. And so this is bivariate, and then the variables would be salary and degree. Can you look at a paragraph, identify either univariate or bivariate, and then explain or give a couple of words about what the variables are? The other piece on this is, can you, right here, 4A, can you do 4A and 4B, where they're asking you to create a number line using this data. I would give you the data, I would give you all of the information, and then I would explain how to create a number line, as in part A and part B, and then could you write a couple of sentences to compare and contrast what you just created. And then correlation. I would definitely know the definitions for positive and negative correlation. And then I'm going to keep going because here, let's put all of this together. Where it says correlation does not always indicate causation, I would highlight that, underline that, and then we've been going around that a whole bunch more with observational versus experimental studies. And then right here, I was telling my kids in class today, my students, can you be creative? Can you think? In other words, like on part A, if somebody did say, every time I eat chocolate, it makes my face break out. Write a couple of sentences about this, like either agreeing and why, or writing in some confounding variables of, it may not be the chocolate, it might be, and write a couple of ideas as to what you think it might be. When we look here at the correlation coefficient, do notice where it says the range at +1 or to -1, those are really, really, really strong correlations, but when you're close to 0, it's no correlation. So think about money. If we are up here close to $1, if we're at 80 cents, that's really a strong correlation. We're up there close to a +1. And so maybe it's like this one right here that says a strong positive correlation. That could be like a 0.80. But then when you get this very weak correlation, we can't even tell if it's going positive or negative. That could be more like something like a negative 0.20, because 20 cents is not close to a negative dollar or a positive dollar. And then looking at this other one here, where we have zero correlation, zero, nothing, nada, no organization. Could you look at and identify and offer comments about positive, weak, strong, negative correlations? And could you give comments whether you think there is a correlation, like in part C right here, the age of a particular model of a car and its value. In other words, as the age increases, does the value increase or decrease? And that could indicate, yeah, it's a negative correlation. It's very strong. But then you might want to throw in comments of, yeah, but when it becomes an antique, it's going the other way because the older it is, the more valuable it becomes. So can you look at something and offer some comments, some thoughtful comments? So here we have some data and a scatter plot of the data. And just realize if I do ask you to do a scatter plot, it's going to have to be just for a very few coordinates. Like this has a whole bunch of coordinates. I can only ask you like 4 or 5 coordinates because you've got to draw it, do the axes, really do them in general, and then put those on there. So a scatter plot is always a great thing to ask. I just can't make it very involved. And again, talking about how to use slope to find the equation, and like right here on part G, can you interpret the slope you found, and can you interpret the y-intercept? That was a very important skill that we did in class, parts D and E, finding the slope, finding the equation, and finding the y-intercept. And so what I'm looking at is question number 5 in this section. That's a whole lot in this poor one section. So moving on to 10A, Fibonacci. I'm not going to ask you about juvenile rabbits or young adult rabbits or adult rabbits. But within that time series model, as we just saw, We were talking about average rate of change. We were talking about delta P over P. We were also talking about right here on question 5 that we did find a relationship of 0.62. And that 0.62 is something that we could use on question number 6 to go from 1 month to the next using the 0.62 and adding it back in. Moving on to 10B, looking at the pieces and parts, population. So I know mine is pretty sketchy here without some parts that are there and they're missing. I can't think of any formulas right now that you need to have memorized except the delta P over P, the change in population over population, the original population, that's relative change. And that's what we're talking about here. But I want to see it on a chart because that's a great place to ask the question. Sketching a model, deer, logistics. Okay, so let me go back up here. So looking back here at is it getting crowded? We did do the hypothetical example of the rabbits, and then we talked about real population data. And let me pause and screenshot this so I can write on it. So something we've talked about in the videos and in our face-to-face classes is that if you were asked to test if this is a linear set of data, in other words, I can have a set of data, and in the data, we'll have numbers all over the place, and I can ask you, is this data representing a linear model? And if it is, then you'll be able to calculate the slopes, like let me change colors, like take the information on these 2 points, calculate the slope, and then find 2 more points, maybe these 2. And when you calculate those points, well, calculate the slope of those points, the slopes should be identical. And if they are, you get to declare, yes, this is linear. But if it's not linear, you need to do a second test. And a second test would be, is it exponential? And so our test for exponential is where we take the change of the population over the population. That is relative change. I know some people in the face-to-face class really like to see it better as relative change. The bottom line on this is, when you're looking at the population, if this is the column for the population, maybe this says the population in 1950, 1960, 1970, etc. You have to have an ending minus a beginning. So we wouldn't be able to calculate what was going on in our very first line. Let me undo these and give me a space over here. So when we're calculating this change in the population, this delta P over P, we would not be able to calculate it for just the first line. Can't do that. But we can calculate it for this line because we would take the ending number here minus the beginning number and divide it by the beginning number, and we can put it here. We did leave it as a decimal, and then we could do the calculation again. We would take ending number minus beginning number divided by beginning number and put it here, etc. Ending number minus beginning divided by beginning, put it here. And then finally, and this is about all I could put on the test because it just takes a while to do. And when you look at all of these numbers here, they need to be either the same or darn close. And if they are, that is our constant of proportionality. And that means that we have an exponential graph. Make sure you're familiar with these tests for linear and for exponential. Not only did we talk about testing for linear and testing for exponential, We then found out, the rabbit population cannot continue to grow forever exponentially. Something else must be going on. And that's when we moved into lesson 11 and we started talking about, as you see on the objectives, that a population can grow at an increasing rate and then at a decreasing rate, and it might be modeling a logistic curve. And we talked about those words of that the curve is going to start off slowly, and then increase rapidly, and then slow back down as it gets towards close to the carrying capacity. So in this lesson, make sure you could calculate, as we did in class, if you have the density of deer or whatever we're talking about and the actual area of the region, could you calculate the number of deer? Could you pull out data from a paragraph, like in 1980 there were no deer, and then we calculated 96 in 2002? Could you do those and graph them and start interpreting that there will be a carrying capacity and that we probably won't get to it? But yeah, we had some really good discussions in class that we could go past it, but then we're going to have to go back down because we're going to run out of resources, and then when we get more resources, we'll head back up. So understand the parts of logistic curve. And in class, we did talk about culling, and that's how we would go below the line of the carrying capacity, but then when it wasn't culling season, then we'd go back above the line. We did a whole lot of talking about the logistic curve. We also included talking about the deer. In other words, where's that island? Here's the island. So we talked about the growth rate here in this lesson. And all of my stuff is not here, but what I want you to focus in on, and we're gone with that lesson. Go back to the objectives. Make sure you know that there is a thing called a logistic curve and that you know its parts: slow growth, fast exponential like growth, and then slow growth as we start becoming asymptotic to the carrying capacity. And with these things in mind, can you describe what's going on? Can you graph this if given some data or given a paragraph with the data included in it? But we kept going. And we were building on the concept that there's this thing called a logistic curve. Then when we got here, we were talking about cell phones. And we were trying to really make sense. Did a cell phone follow a logistic? Did it not? And then we talked about this formula. Make sure that you see the formula there, the y equals a over 1 plus parentheses x over c to the b power. Make sure that if I was to give you that formula and I gave you a, c, b, and x, could you calculate y? I can ask you to find a, and I can ask you to find c. I will not ask you to find b on the test. I'm going to keep scrolling down. We're now at the hares and lynxes, and we were thinking, wow, linear is a great model, so is exponential, logistics super also, but then, if the animals interact with each other, what could happen? And so in something like this, make sure that you know, moving on to here, well, we had a lot of stuff going on with formulas here. And we had direct proportion. We had putting the formulas together. Let's go on and look at the next lesson on the reindeers and lichens. Where is... this was still stuff we did on the spreadsheet. That was still playing around with the spreadsheet. And both of these ended up being cyclical. And inside, because you're not going to be able to graph, you're not going to be able to do Excel sheets during the test. Let me see what's coming up next. Okay, we're now at 12. So going back to the cyclical, Make sure that you can calculate amplitude. Make sure that you can calculate period. Let me go get a picture for that, for this 11E and 11D on the cyclical graphs. So for 11D and 11E, make sure that you know what period and amplitude are. Here are some examples giving some drawings, like when we go to calculate from the first peak to the second peak, then we can find that it's taking 2 years. And then the peak minus the, wait, hang on, amplitude is taking 2. In other words, it's taking 2 years to go a complete cycle. If you wanted to go valley to valley, you could do that too, from 2012 to 2014, subtract these. It's taking 2 years to go through a period. But for us to calculate amplitude, we need to subtract a highest point, say a highest point minus a lowest point, and then divide by 2. So the height of our graph divided by 2. So our highest point's right at 100, and our lowest point is right at 20. So 100 minus 20 is 80, but we divide by 2, and that gets us 40. So this line right here at 60, that's like the middle of our graph where we go up 40 and down 40, our amplitude, and that is the picture of our graph. So make sure you know period and amplitude. So I've skipped over the lessons in 12, and I've gone to lesson 13, and I will have many students say, we love lesson 13 because it's a lot of words, and I'll have a lot of other students who will say, we hate lesson 13 because it's a lot of words. Just be aware that you're going to need to know the words, the definitions, the processes of all the pieces and parts of lesson 13A. And with that being said, everything that we see, especially the stuff in bold, make sure that you understand what a sample is and the statistic that goes with the sample, and explanatory response, quantitative, categorical. What are these words, and then how were they asked in our lesson? And for the most part, we're asked to read through a paragraph and then start picking out parts like, is this a census or a statistical study? And then what kind of statistics were we studying? And what are the variables? And then classify the variables. Would you call them quantitative or categorical? And I know in class, we've gone back and forth that we disagree that some really could be categorical or quantitative. And on the test, you just need to explain. It doesn't need to be a huge paragraph, just a sentence. I believe it's quantitative because. And then we talked about summary values, like we'll find averages on quantitative and percentages of categorical. And then can you identify explanatory and response variables inside a paragraph? Which ones are they? And what's their purpose? What are they telling us? And is it happening in an observation, or is it happening in an experimental study? There are so many words that at the end of this lesson 13A, they gave us a list. Make sure you are extremely familiar with those words. And then, true to form, we're talking more about the words and we're practicing the words. We practice with study X, which is observational, and study Y, which is experimental. And then we start writing. And so make sure that you're coming up with some words that you can use appropriately on the test. Like on question 4, when it says it's an observational study, make sure that you write conclusions that are observations. You cannot use the word cause in observations. But when we got down here to part B, where we actually manipulated the diets of the members of this sample, we do get to say words like cause if we've got a good study, and if, so many ifs, but we do not say it on observational. Make sure you're familiar with the words and that you can pick out thoughts in the paragraphs. We will finish up these lessons like at 13C. It's talking about a simple random sample. And I can put something like this on the test. I can give you a chart like this. I can ask you to conduct a simple random sample, and you got to know which one that is. Like looking right here where it says, can you use a random number generator? Can you pick some numbers? I can't get you to pick 20 on the test, but I can get you to pick 10. And then you can identify them. You can show me how you went random, and then you can show me your statistic, like if you computed an average. You can definitely do that, but you've got to know what a simple random sample is and what you would do to calculate it. You also need to know what's absolute error, because if I say, here, by the way, is the mean of the population, take your sample mean and the mean of the population and calculate the absolute error. You need to know how to do that. And then finally at 13D, wait, there's more. We're going to do something different. And you notice in bold it says a stratified sample. And all of this is going to look really familiar, but I can ask this on the test too to conduct a very small stratified random sample. And this is where you got to make yourself a huge note that it involves percentages of subgroups. And then what we would do with the subgroups and how many we would need and how can I conduct this study as compared to the simple random sample. And again, you would need to know how to calculate the error of between the population and your sample. And I believe that was it, because that was 13D. So that's a lot of talking and a lot of words, but hopefully some information that'll help you prepare better for the test. I have posted the dates for the online portion of the test. Go back and look at that in our announcements. And I'll be giving you more directions, but it's the same ones I've given for test 1 and test 2, of making sure you contact the testing center, that you're looking at their hours of operation, and if they've got anything weird going on the day you want to go. In other words, try to not have surprises when you end up at the testing center. So I wish you the best on this test, studying for it and taking it, and I'll see you in some of the next videos, but good luck getting ready for test number 3.